Hi everybody, this is Michael from coachapilot.com. I am an ATPL instructor. I've been teaching for 12 years different ATPL subjects. And over the years, I've worked a lot with smart people, so a lot of ATPL students, obviously, and also professional pilots converting their license to EASA. And I noticed that these people actually knew a lot the theory very well, but in spite of that, they were still making lots of mistakes in the exams. So what I realized is that most ATPL mistakes are not knowledge errors. They are interpretation errors that are caused by wording. There is a concept in neuroscience that is called the free energy principle. Simply put, the brain is constantly trying to reduce the level of efforts, to reduce the uncertainty, and to avoid surprise. So this is what happens when you are doing question banks at the ATPL, because basically you answer a question, you find a good answer, and the next question that is pretty similar to this previous question, your brain will go directly to the answer that is similar to the one that you've chosen before. The problem is that the ATPL exams play with that, and they do exactly the opposite. They increase uncertainty on purpose, mainly through ambiguous or misleading wording, intentionally. So this is a game, and what I teach in my coaching session is not how to memorize, or is not how to memorize more. It's basically how to stabilize your mental model before you answer, so you can predict the trap instead of reacting to it. At the end, the ATPL is a game. I tell that to the student a lot, and my mantra is simple: trick the trickster. So let's look at a perfect example of how this works through two questions of principles of flight. So let me show you a trap that catches a lot of smart ATPL students. Not because they don't know the theory, just because the question literally pushes their brain in the wrong direction. So here you have two different questions that look almost identical. So an aircraft decelerates from 1.4 vstall to 105 vstall. What is the percentage increase in the lift coefficient? So you see that in this one is expressed as a percentage of CL max. In the previous one, it's just what is the percentage increase in the lift coefficient, with no more information. So what happens is that usually you recognize the question, you feel confident, you answer too fast, and eventually that confidence is exactly the trap. Okay, and most ATPL mistakes, this is important to have in mind, are not knowledge error. They are actually just interpretation errors that are caused by wording. So let's solve them. In the first question, 1.4 vstall to 1.05 vstall, this is the decrease in speed. So obviously, associated to this decrease in speed, we have to analyze the change in CL. Okay, so we start with the same formula as usual. You have seen it a lot, probably in my previous video. Half of density times v squared times surface times CL. If the speed decreases, CL has to increase. And then how much is the increase of CL? Easy. The change in speed, the change in CL is actually a function of the change in speed. So you have this formula that works all the time. V times X gives the CL multiplied by 1 over X squared. Okay, this one you can take it because it works absolutely all the time in this type of question. Example, the speed is doubled, the CL is divided by 4. As simple as that. Okay, just we don't have to think too much about that. Then we have two speeds, the new speed, the old speed. So the change in speed, the X that we are looking for, is 1.05 divided by 1.4, which is 0.75. Corresponding change in CL, easy, 1 over 0.75 squared, which is 1.78, something like that. So the CL has been increased by 78%. Okay, easy. So you solve this one, you click on 78%. Okay, let's see the question. This is the answer, 78%. Fine. Then, second possibility, second scenario, you see this question. Again, an aircraft decelerates from 1.4 vstall to 1.05 vstall. What is the percentage increase in the lift coefficient expressed as a percentage of CLmax? Super confident, you click on 78, and it's not the good answer. And this is what I did, by the way, with one student a few weeks ago. And actually, this happens because there is just one simple sentence that changes in the question, and you have to take it into account. So expressed as a percentage of CLmax. So as a reminder, CLmax is the maximum coefficient of lift. This is where you are when you are at the critical angle of attack. Okay, so then the purpose of this one is totally different, because it's actually to determine at 1.4 vstall how much is the CL as expressed as a function of the CLmax. So 1.4 vstall, CL equals the CLmax times 1 over 1.4 square. Same operation as what I did in the previous question. V times X, CL times 1 over X squared. As simple as that, okay? We keep it simple. We don't complicate too much. CL max is multiplied to 1 by 1 over 1.4 squared. Okay, so the CL is approximately 51% of the CL max. And by the way, and then we do the same in the next speed, 1.05 vstall. And by the way, we can place these two speeds, and we see that at 1.05 vstall, we have decreased the speed, so necessarily the CL will be more than 51% of CL max. Same operation, CL equals CL max times 1 over 1.05 squared, and the CL is actually 91% of the CL max. And then to solve the question, we have observed the two situations. We were at 51% CL max, and now we are at 91%. So we have an increase in CL as expressed as a percentage of CL max of 40% of the CL max. Okay, to pass from 51% to 91%, it's 40% more. Problem solved. So you see that here, initially I clicked on 78% because I thought it was exactly the same question as previously, and is not definitely not the same, unfortunately. So you see that this is exactly what I want to show you in my coaching sessions, because it's not a question of being smart, it's a question of paying attention to all the single sentences and the wording of the questions, because this is what makes the difference, literally. All right, I hope you liked the video, and if this way of thinking actually makes sense for you, if it makes this ATPL question clearer, I'm very happy. And I wanted to show you that because this is my method. This is exactly how I work in my coaching sessions with the students and the professional pilots that are following me. So if you want to train this mindset consistently, just get in touch. You have my contact on this slide. And remember, trick the trickster.